This is homework set 41. We're now looking at systems of linear equations in 3 variables. Question 1. We are asked to solve this system of 3 linear equations in 3 variables. I'm going to start by naming these equations. I'm going to call the top one equation 1, the middle one equation 2, and the bottom one equation 3. Our plan is to reduce this 3 by 3 equations, 3 variables, this 3 by 3 system down to a 2 by 2 system, which I already know how to solve. So I'm going to do that by trying to eliminate one equation and one variable. All right, that's our plan. Eliminate one equation and one variable. Now, as I look at this system, I see that, you see these y's here? They're just the same coefficient but opposite sign. So if I look at 1 and 2, if I just added 1 and 2 together, the y's are gone. And if I add 1 and 3 together, the y's are gone. So I think I can eliminate y by doing this. Eliminate y by taking equation 1, adding it to equation 2, then equation 1, adding it to equation 3. Now, essentially what I'm doing is I'm using equation 1 as a pivot. I'm going to start here with equation 1, use equation 2. Then go back to 1, use equation 3. Let's see what happens. So equation 1 plus equation 2, you may be able to do it in your head, but I'm going to write it out here. Equation 1 plus equation 2 looks like this. X plus y plus z equals 10, and then x minus y plus 2z equals 2. And if I add them together, I'll get 2x, the y's are gone, 2x plus 3z, that's equal to 12. All right, now this is a new equation. I'm going to call that equation 4. All right, now I used 1 and 2, now let's use 1 and 3. I'll do that up here at the top. All right, so equation 1 plus equation 3 is going to look like this. X plus y plus z equals 10, and equation 3, x minus y plus 3z equals 4. And when I add these together, I'll get a 2x, again the y's are gone, that's why we did it, plus 4z equals 14. And you know what I'm going to do here? Because each one of these coefficients is even, I can reduce this equation just by dividing everything by 2. All right, so if I divide by 2, this becomes x plus 2y equals 7. And there's a new equation, not 2y, I'm sorry. Let me get rid of that. That's 2z. That's equal to 7. So that's a new equation. I'm going to call that equation 5. So now I have this new system, equations 4 and 5. I'll write them here. So we have this system, 2x plus 3z, that's equal to 12. That's our equation 4. And then we have this new one, x plus 2z, that's equal to 7. That's our equation 5. And there's our new system. So now it's just like a new problem here. Now what I have to do is just solve this by, maybe I'll use, well, I could use substitution, right? Because I just got a 1x. It's easy to solve this for x. So I could solve it for x. But I think what I'm going to do is just use addition. So my plan is I'm going to eliminate I'm going to eliminate x. And here's how I'm going to do this. I have a 2 up here. I would like a negative 2 down here. So I'm going to multiply equation 5 by negative 2. So here's what I'm going to do. Negative 2 times equation 5. And I'm going to add that to equation 4. All right, here's what it looks like. Pass a negative 2 through here. So multiply everything here by negative 2. I will get negative 2x minus 4z equals negative 14. And now equation 4 looks like this. 2x plus 3z, that's equal to 12. And when I add these together, the x's are gone. I get negative 4z plus 3z is negative z. That is equal to negative 14 plus 12 is negative 2. So z must be 2. Well, now I've got z. So why don't we just put z back into one of these equations up here? What if I just put z right here? Or if you like, no problem, you can put it right back here. But put it back into a system where you just have x and z. So now I'm going to put z into equation 5. So that's what I'm going to do. I'm going to substitute 2 for z in equation 5. So just bring it down here, all right? So I'm going to put that 2 right into here, and we will get this. X plus 2 times, now z is 2, so I'll put a 2 there. That's equal to 7. So x plus 4 is equal to 7. Subtract, I get x equals 3. So now I've got x being 3. I've got z equaling 2. So take those two values and go back to one of the original equations. Doesn't matter which one. Put 3 in for x, 2 in for z, and let's see if we can get y. So I'm going to do this. I'm going to substitute into, just pick one of the equations. It doesn't matter. I'll pick one. All right, so I'll get this. Here's the equation. X plus y plus z equals 10. But x is going to be 2 plus y. No, I got that wrong. X is 3 plus y plus z, which is 2. That's equal to 10. So this is 5 plus y equals 10. Subtract. I'll get y equals 10 minus 5 is 5. All right, I've got them. So here's I'm going to call it an ordered triple. X is 3, y is 5, and z is 2. Question 2, we have a 3 by 3 system, 3 equations, 3 variables, x, y, and z. And our plan is to use maybe the addition method to reduce this to a 2 by 2 system. We'll eliminate one equation and one variable. Our first decision is which variable do we want to eliminate. Now last time we eliminated y. I could eliminate y this time because I got a plus and 2 minuses. All right, that makes the computation a little bit faster when you have opposite signs. I could eliminate z, but just for fun, why don't we eliminate x? They're all the same sign. So that's my plan. I am going to eliminate x using, all right, now what I'm going to use is, I might as well use equation, let's name these, okay? This is equation 1, that'll be equation 2, that'll be equation 3. So I can pick a pivot. I'm going to pick this one here. I'm trying to eliminate x. I got a 1 here. It makes multiplications easier when you have a 1, but it really doesn't matter. So I'm going to use this. I'm going to use 1 and 2, and then 1 and 3. All right, so the plan is now using 1 and 2, then 1 and 3. Now with equations 1 and 2, right, with 1 and 2, I want to eliminate x. So look at 1 and 2 here. Now with 1 and 2, I can eliminate x if I get that to be a negative 2. All right, then negative 2x plus 2x would go out. So I can get this to be a negative 2 if I multiply by negative 2. But I have to multiply all the way through by negative 2. So the plan is negative 2 times equation 1 plus equation 2. Now that's going to look like this. Just multiply everything up here by negative 2. It will be negative 2x plus 6y minus 2z equals 2, right? I multiplied everything by negative 2. Negative 2 times 1, negative 2. Negative 3 times negative 2 is the 6. 1, positive 1 times negative 2 is negative 2z. And negative 1 times negative 2 is 2. Now equation 2 we're not changing. That's just 2x plus 3y plus 2z. That is equal to negative 2. Oh, look at this. The x's go out. I get a 9y, but the z's go out also. 9y equals 0, so y is 0. So now that I know y is 0, why don't I just put that y equals 0 into these equations here? All right, now I think what I'll do is I just need 2. I'm going to pick 2 and 3. All right, for no particular reason. I'm just going to pick 2 and 3. So if I put y equal to 0 into 2 and 3, all right, so here's what I'm doing. Putting y equals 0 into equations 2 and 3. Here's what it'll look like. 2x, now y is 0, so it's gone, plus 2z is equal to negative 2, and then to equation 3, I'll get 3x, and then minus 3z, that's equal to negative 12, all right? Now, I'm going to call this equation 4, and this equation 5. So I see I have opposite signs here. Why don't I eliminate z? All right, so that's my plan. I'm going to eliminate z. So what do I need to do? I need to get these to be the same number here. So what if I multiply this one by 3, this one by 2? All right, so let's do that. So the plan is this. I'm going to take 3 times equation 4 plus 2 times equation 3, and it will look like this. All right, 2 times or 3 times this one right here. I will get 6x plus 6z is equal to negative 6. And then I get multiply this one here by 2. All right, by 2 I will get 6x minus 6z is equal to, I'm multiplying by 2, so negative 24. All right, so I get 12x, the z's are gone, equals negative 30. So x is equal to negative 30 over 12. I can divide each one by 2. All right, so actually I can divide by 3, right? So negative 10 over 4. Now I can divide by 2. X is equal to negative 5 over 2. So now I've got x. Now I've got y. So why don't we just substitute these into, doesn't matter, pick an equation. How about number 1? Okay, so here's equation 1. X minus 3y plus z is equal to negative 1. Now x is negative 5 halves. This is 0 now, right? 3 times 0 plus z, this is negative 1. All right, now this is gone, so I get negative 5 halves plus z is negative 1. How about z is equal to, just add that to both sides, so I'll get negative 1 plus 5 halves. Okay, well, z is equal to, this is negative 2 halves over 2, just to get a common denominator, plus 5 over 2. So I end up with 3 over 2 for z. Okay, so now I claim that I've got it. Here's what I think I have. X is negative 5 halves. Y is 0. Z is 3 halves. I'm going to claim that that is the solution to this system. That will end this little part of homework set 41.